So it turns out that CS61A Plus is still unpopular despite having that one add friend method. So to attract more users, the TAs want to implement another feature, and that feature is going to check if two users have at most n degrees of separation. So you might have heard, for example, like of the 6 degrees of separation, where you can reach any person from another person using a chain of 6 friends. And this is pretty similar to that. We can just look at the examples. So by definition, there are 0 degrees of separation between a person and themselves. There's 1 degree of separation between Robert and Jeffrey because they're direct friends. So if you look in Robert's list, there's Jeffrey in there, so they're friends. There's 2 degrees of separation between Robert and Yulin because Robert is friends with Jessica, who is friends with Yulin. And the degree of separation between Albert and anyone else is undefined because Albert sadly has no friends. All right, so let's take a look at the skeleton here. We basically have what seems like some base cases, and then maybe we'll have some sort of recursion in here. This seems like a very naturally recursive problem. Let's talk about why. So if I were to try to just solve this as a human, maybe by solving this base case between Robert and Yulin, 2, then I'd say, okay, first, maybe I can look in Robert's friends. Yulin isn't in Robert's friends, but maybe then I'll look at the friends of Robert's friends, so Jeffrey's friends. And Yulin is in Jeffrey's friends, so that means that we found 2 degrees of separation. But what did we really do here? Well, we said that see if Robert and Yulin are 2 degrees of separation away, which is the same thing as going through Robert's friends list and seeing if Jeffrey or Jessica are 1 degree away from Yulin, which is the same thing as going through Jeffrey's friends lists and seeing if Robert or Jessica or Yulin are 0 degrees away. Because each time we go through someone's friends list, we delete 1 degree, right? We go 1 degree down the chain. And that's going to be the basic structure here. In our for loop, we can iterate through self.friends. Is there a self? Yeah, because we're in the network class. Of user 1. We could also do user 2 to go backwards, but why not just go forwards? And we iterate through those friends, and then we see if self.degrees of that friend and our target user, if they're n-1 or less degrees away. So every time we go through a friends list, we just reduce the degrees by 1. Great, so let's also figure out what we return if none of these are true. So either if you don't have any friends or none of your friends are like the right amount of degrees away, well, then you're not, by definition, that many degrees or less away from user 2. So then we can just return false. Finally, we have to think about some base cases. So let's first just think about what are some simple inputs to the problem. Well, the simplest one I can think of is this doc test, where you just get in Robert and Robert. And if you get user 1 and user 2 as the same person, then by definition, as long as there's a positive or non-negative degree of separation, which there always will be, then we return true. So if user 1 is equal to user 2, then they're always 0 degrees of separation away, so we can return true. But what if we've gone all the way and we've decremented this n all the way down to 0, and still we have some input like Robert and bread, comma 0. Well, Robert, Bread, and 0 are not, it will not return true, ever. Because Robert and Bread are not 0 degrees of separation because they are not equal. So as long as n is equal to 0, we want to return false. Because if n is equal to 0 and user 1 is not equal to user 2, only then are we going into this elif case. And we could also do less than or equal to 0, which I believe the answer he does, but I don't believe we'll ever get to that. And yeah, that should be it. Feel free to leave any questions on Piazza.